Hello my dear friends, very good morning to all. So in the last class I think we discussed some theoretical sessions regarding the parallel circuit, parallel resonance, series circuit, series resonance and all, and I think we didn't do so many problems regarding series, parallel circuits and resonance conditions and all, and Rms value, average value, etc. So I am decided to do some more problems regarding, some more practice problem regarding those RMS average value concept, and it is very important. So many questions will be asked from that session. So more than knowing better theory, more than knowing the theory better, you have to make sure that you have to do a problem. If it is whether it is from RMS average value concept or resonance concept or anything. So you have to learn the theory first and later you have to practice more problems. Then only, see, the idea in theory is simply we are grasping or gaining some knowledge, right? Whenever it is needed, if we apply that, then only we say that we studied or we learned. That is the meaning of learning. So learning is a process actually. You have to learn. The learning process is not completed. If you apply that to any situation, right, any problem, right, then only that learning process has completed. So let's do some problem so that we check whether we learned properly or not. Okay. So let's do some questions. So let's write a question. If z is equal to 3 plus j4, then find G, simply conductance, comma susceptance. Simple question is this actually. So now in a one word answer type questions you may expect in your examination. So it may not be a big question. Or it is simply a question, but you have to think a little, right? You think for some time, then only it will definitely the answer will come. So that type of question is this. So looking in the first instant, it is very, you may might feel that, oh, how can we find that? Is it easy? No. Okay, how can we do this? You may be confused sometime, right? So let's do that. So if z is equal to 3 plus j4, then find conductance and susceptance. How can we solve for such a question? Okay, listen. So we have z is equal to what? 3 plus j4. Then what is y? Y is nothing but 1 by z, which is nothing but 1 by 3 plus j4. 1 by 3 plus j4. Is it possible to directly take the value of conductance and susceptance from this? Is it possible? No. We have the equation as y is equal to g plus jb, where g is nothing but the conductance and b is nothing but the susceptance, or g is nothing but 1 by r and b is nothing but 1 by x. Is this XL or XC? Anything 1 by XL or XC. That is the susceptance. That is 1 by reactance is called as a susceptance and 1 by resistance is termed as the what? Conductance G. So this is, we already know, right? Y is equal to G plus JB. So in order to form Y is equal to G plus JB format, how can we do in this equation? See, simply Y is equal to 1 divided by 3 plus J4. Oh, how can we convert it in the form of G plus JB? So there a mathematical trick we are using, that is nothing but we have y is equal to 1 divided by 3 plus j4, right? We have to multiply both the numerator and denominator with the conjugate of the complex equation. So this is a complex equation, right? A plus jb format, right? Which means a real part and an imaginary part. That is why it's called a complex equation. So for that equation you have to make it convertible, like y is equal to g plus jb what we have to do is we have to simply multiply the numerator and denominator with the conjugate. The meaning of conjugate of any equation is that suppose a plus jb, we have to find the conjugate. Conjugate is represented by like this, is nothing but a minus jb. That means, or we have a conjugate like 3 minus 4j. We have to convert or find whenever it is given in a question to find its conjugate means simply you have to change the sign of imaginary part. Very, very important. So conjugate is nothing but changing the imaginary part sign. That is the meaning of conjugate. So its conjugate will be simply 3 minus j4 divided by 3 minus j4. Is it any change in this equation? No. Because I multiply and divide both with, that is numerator and denominator with the 3 minus j4 is nothing but conjugate, right? So the answer will be, how can write for 3 minus j4 whole divided by, see a plus b into a minus b format, is it correct or wrong? A plus b into a minus b, what is the meaning of a plus b into a minus b? It is nothing but a square minus b square, b is nothing but j4, right? A square minus b square, correct? So it will become 3 minus j4 whole divided by 9 plus 16. Am I right or wrong? Am I right or wrong? Because here it is minus is there and j square into 4 square, that is the meaning of j4 the whole square, right? J square is minus 1, correct or wrong? Yes, j square equal to minus 1 and 4 square is equal to 16. So minus 1 again minus 1, it will be plus 16. So my answer will become y is equal to, how can I write this? Y is equal to 3 by 25 minus j into 4 by 25. Is it correct or is it correct? Yes. That means this is in the form of what? G minus jb format, right or no? It is now in the format of G minus jb. G minus jb. So by looking the equation y is equal to G minus jb, can you predict whether it is an inductor circuit or capacity circuit? Can you predict that? G minus jb is for inductive circuit. Is for inductive circuit. We learned already that R plus jxl, z is equal to R plus jxl. xl is for R plus jxl is for inductive, right? And z is equal to R minus jxc for capacitive. We know that in series circuit, right? In series circuit, the opposite will be in parallel circuit. That means it is or y in terms of y. When it write in terms of y will be G minus jb will be in inductive manner or in inductive circuit. That means if you take 1 by z and if you cross multiply, you have to prove this. Can I prove this? How can we obtain? So see from this also, z is equal to R plus jxl, right? Z is equal to R plus jxl. It is an inductive, no? Whether we have to convert it into admittance term also, there is an inductive circuit, right? It will not change, no? So by observing the y value, y is in the form of G minus jb. So simply by looking at y also we have to predict, or we can able to predict whether it is an inductive or capacitive circuit. So simply looking into y term, y is equal to G minus jb, also we can predict it is an inductive circuit, right? So for confirmation, I already saw a z value. Z is R plus jxl, taking the y, so y is equal to G minus jb. So you can say that here it is G is nothing but 3 by 25. What is the unit of G? It is ohm raised to minus 1, correct? Ohm raised to minus 1, correct? And susceptance also, susceptance is nothing but B, it is nothing but what? 4 by 25, right? No need to write the minus 4 by 25 rule, because it is a inductive circuit. We know that the susceptance will be that also in terms of ohm raised to minus 1, because both inductance and susceptance having a unit of mho or ohm raised to minus 1 or Siemens. That also a unit, right? Siemens. That also a unit of what? Susceptance or conductance. Susceptance is normally referred to as Siemens or ohm raised to minus 1. Is it clear? Okay. So that's all about the fundamental, right? The fundamental. Now you learned a fundamental also, right? Mathematical trick in order to convert a conjugate complex equation to a simple form, right? A plus jb form. Even it is not in a plus jb form, we can convert into a plus jb form by simply multiply with the numerator and denominator with the what? Conjugate of the equation, right? So that's all about the equation, question. I think it's very clear to you. These all are fundamental actually, no? But you have to know this, Clear? So let's take a next question. Find the voltage in the circuit, right? Find the voltage in the circuit. Okay, a simple circuit is given. We have to find the voltage in the circuit. That is nothing but this voltage you have to find, right? This voltage you have to find. How can we solve such a question? Maybe if you don't know really the concept, if you see the same question in your examination, then if simply you thought about what? 4 and 5, 9 plus 2, 11. Of course, there will be 11 as one option in your answer. Okay, so what will you do? Simply give a tick in your 11 volt. Is it correct? It's wrong. So you have to know the basics of series RLC circuit and how can we take the resultant. Then only this problem can be solved. Okay, let's see. So we know that in a series RLC circuit, the resultant voltage V is nothing but root of VR square plus VL minus VC the whole square, or VC minus VL the whole square, depending upon the value of VL and VC. This is the equation only we need to solve this problem. If you don't know this equation, then definitely you can't answer this. Oh, is it correct? You can't go for a simple arithmetic. 5 plus 4 is 9, 9 plus 2 is 11. It's wrong. So what will be the answer? It will be simply root of 4 square plus VL minus VC the whole square. Now it is VL is higher than VC, so VL minus VC the whole square. 5 minus 2 the whole square. Or simply root of 16 plus 9. 5 volt. So that is the answer. See how beautiful this question is. And it's a one-word question actually, one-liner question actually. But I think you have to think. You have to think in order to answer this problem. Correct? Making an error, chances of making error is very high. The probability to make the error is high in this question. Okay? So that's about that question. Okay? And see next question. Find the voltage across the resistor in the circuit. In the circuit. Next question, that is the find the voltage across resistor in the circuit. Can we solve this? It's very easy, It's very easy, How can we solve for that? We have the same equation like 120 is equal to root of VR square plus, what is that? Let be simply 12, okay, 12 volt. Okay, so 12 square equal to, that is simply 12 is equal to, okay, let it be 12 volt, okay. So 12 is equal to VR square plus VL minus VC the whole square, right? VL minus VC the whole square, right? So it will become root of VR square plus VL minus VC is nothing but 2, 5 minus 2, right? So it will be 3 and 3 square is 9. So it will be 12 square, that is, let be 144 equal to VR square minus 9, or simply VR square equal to 144 minus 9, or it is nothing but 135, right? Am I correct? 135, right? So it will be VR equal to root 135 volt. So that is the answer. So that is the answer. That is the answer. Is it clear to you? Is it clear to you? It's very basic actually. It's very, very basic. It's very, very basic. Correct? Okay. So let's go for another question. Sorry. Find the total current. I know my handwriting is very, very poor. I don't know. I know this. Total current in the circuit. Okay. How can we find? How can we find the total current? How can we find the total current? It's a parallel RLC circuit, right? It's a parallel RLC circuit. So we learned in a parallel RLC circuit, like the series RLC circuit, always go for the algebraic sum of voltages, right? So in a parallel RLC circuit, there is an algebraic sum of current. There is an algebraic sum of current. That means we can say that I is equal to, it is actually vectorial. I is equal to IR plus IR plus IL plus IC. Or when we taking the magnitude, of the I, we will have I will be equal to root of IR square plus IL minus IC or IC minus IL the whole square. IR square or IL minus IC or IC minus IL the whole square. That we already learned. In an equation we already learned, no? In equation we already learned, right? IR, that concept we already learned. So that means there is a circulation of current between L and C. That circulating current is nothing but 5 minus 4 ampere, that is nothing. 1 ampere is circulating around this LC circuit. In a loop, it forms a loop actually. So for this circuit, it is only 1 ampere is circulating here. So we can say that, see, the answer will be nothing but root of 3 square plus IL minus IC or IC minus IL, whatever, or when it is IC greater than IL, it will be IC minus IL or reverse. So it will be 5 minus 4 whole square. So it will be nothing but 9 plus 1, root 10. So that is the value 5. Unit is ampere. See how simple the question and how conceptual is the question. You have to think of that. Is it clear? Okay. So let's do another question. in given circuit, find A3. So this is you have to find. This is you have to find. Hundred sin omega t. How can we find that A3? How can we find that A3? Simple. How can we find that A3? That A3 is nothing but root of IR square, that is nothing but phi square plus IL minus IC. No? There is no IL, so simply it will be IC. So 12 square. So our answer will be root of 25 plus 144, right? So it will be root of 169, or A3 is nothing but 13 ampere. A3 is nothing but 13 ampere. A3 is nothing but 13 ampere. 169, right? 125 plus 144, it is nothing but 169. Is it clear? Is it clear? Okay. Is it clear? And now we have to learn some basic about, then only that 2-3 problems, okay, आगे 2-3 problems you have to do, okay. So let's see complex form representation. I think you know this, but just I have to refresh you, okay, I want to refresh you. So complex form representation is nothing but any quantity like z is equal to, any quantity like say z is equal to, can be represented like a plus jb. This is called the complex form representation. That means pictorially or graphically we can say like this: this is nothing but z and this is nothing but theta, and there are two components which is nothing but one is a and another one is jb. And that z is nothing but a plus jb, or mod z is nothing but root of a square plus b square, and tan phi or simply theta, let be theta itself. Tan theta is nothing but any angle, no? Regarding theta, an angle. Tan theta is nothing but b by a. Tan theta is nothing but tan theta from this tan theta, opposite side by adjacent side. It is b divided by its a. And this j represent compared to this a, b is 90 degree anti-clockwise leading. That is the meaning of plus jb. Suppose this is nothing but see, this is the representation. This is a and this is minus jb. Then also we can represent some z value like this, this is theta, so that we can say that this z is nothing but a minus jb, and the mod z is nothing but root of a square plus b square. There is no change in modulus, whether it is plus jb or whether it is minus ab, there is no changing that. And here also tan theta is nothing but minus b by a, that means an angle which is connecting two sides, simply tan theta, that's all. Tan theta equal to minus b by a, and here minus j beta indicates that here with respect to a, b is 90 degree anti-clockwise direction lagging. That is the meaning. That means jb is lagging, of course b is lagging, not jb, b is lagging. How much it is lagging? That is represented by this minus j. Minus j means it is lagging behind a by 90 degree in anti-clockwise direction. These all are phases, beta. These all are phases. Phases are always rotate in anti-clockwise direction. This z is a phasor, right? This z is a phasor. Z is a phasor. This is actually vector, no? Vector you can say, but in electrical that vector is represented as phasor. Phasor. What is the meaning of phasor? Means it is nothing but a rotating vector. Simply a rotating vector is called phasor. A rotating vector is called phasor, which rotate in anti-clockwise direction. That's all. That's all about that phasor. So phasor is nothing but it's a vector, but it's rotating in nature. It's rotating in nature. So here Z is a phasor. We can say that Z is a phasor. In previous problem, I is a phasor, voltage is a phasor. We can say that now complex representing terms all can be considered to be phasors. All can be considered to be phasors. Okay, so that all about the complex form representation. That means, and what is the use of complex form representation? That's you have to ask me, right? That's you have to ask me, no? The use of complex form representation is that whenever we have to add or whenever we have to subtract two complex numbers or two phasors, that should be in complex form representation. That means I will repeat again, whenever there is a demand, whenever there is a situation of adding or subtracting two phasors, you have to be take care that two will be in complex form representation. That means let x is equal to a plus jb, one phasor, and let y is equal to c plus jd, another phasor. If you have to add this phasor x plus y, these all are phasor, no? X plus y, you have to simply add the real term a plus c plus j into, you have to simply add the complex, imaginary part, p plus d. That is the answer. That is the answer. At the same time, suppose you have x is equal to a plus jb and y is equal to again c plus jd. Suppose you have to find x minus y, then you have to simply subtract this real term a minus c plus j into, simply subtract this d, means complex, imaginary terms. So whenever there is a demand or whenever there is a need, whenever there is a situation of adding two phasors or subtracting two phasors, we have to represent that phasors in a plus jb format. That is the application of what? Complex form representation. That is the application. Whenever we have to add or subtract phasors, we have to use complex form representation. Addition means simply adding real part plus imaginary part. Subtracting means again subtracting real part plus j into subtracting imaginary part. Bus. Is it clear? Is it clear? Okay. And next representation is nothing but polar form. Polar form is nothing but beta z is equal to r angle theta representation. Z is equal to r angle theta representation. This r angle theta is nothing but cos theta plus j into sin theta. That is nothing but, this theta is nothing but, that's r angle theta is equivalent to, this theta is, this is equivalent to r into cos theta. This is equivalent to r into cos theta plus j sin theta. Okay, that means in complex form also you can write like, see, this is magnitude 1 and this is cos theta, this is j sin theta, and this is nothing but r. No, it's simply r, yes, correct. Cos square plus sin square 1, this is set. Okay, that's all. This is 1. So this is nothing but the concept of, see, taking the modulus, we will hit cos square theta plus cos square theta minus sin square theta, right? Cos square theta, not minus sin square theta, cos square theta plus this sin square theta. Suppose you have to take the modulus, that is nothing but the magnitude 1, which is nothing but cos square theta plus sin square theta. Correct or wrong? Correct or wrong? So this is where you can represent that cos theta plus j sin theta. Clear? That means this z is equal to r angle theta represent. You don't complicate this. Okay, don't complicate this. Simply you learn. Okay, don't complicate this. Simply you learn. In polar form, we can represent any form, any phases in z is equal to r angle theta form. R angle theta form, where r is nothing but magnitude and theta is nothing but angle or phase angle. Theta is nothing but angle. That means, suppose any phasor which is in the form of a plus jb, suppose you have to convert this phasor to polar form, means you have to know two terms here. You have to know r and you have to know theta. From this complex form representation, what is theta? Theta is nothing but, I already said to you that it is tan inverse b by a. And what is r here? R is nothing but root of a square plus b square. Bas, khatam kali. Is it clear? So that is called the polar form representation. Then again you should ask me that why I have to convert to polar form? Beta? Why? The answer is, suppose two phases, whenever there is a situation you are going to face such that there should be the multiplication or division of phases. There should be the multiplication of division or division of two phases. Then you have to convert first that phases into polar form. Then only you can multiply. Then only you can divide. Let's see how it is. Suppose you have a phasor like x is equal to a plus jb. Okay, simple, explicitly a plus jb, and y is equal to again c plus jd. This is you are, suppose these two complex form you already given as a question. It of course have some value, no, 2 plus 3g or 5 plus 6j or etc. You have to find what is x into y. Suppose someone asks you to find x into y. You can't directly multiply this a plus jb into c plus jd. You can't directly go for that. But there is a chance of errors. So better or easy way, you have to convert it into first into what? Polar form. How can we find the polar form representation? Take the angle of this first. That means this has to convert into polar form as x is equal to what? Take the magnitude of this equation. What is the magnitude of this equation? Which is nothing but a square plus b square. Angle, take the angle tan inverse b by a. Is it clear? And what is y will be? Root of c square plus d square, that is a magnitude, angle tan inverse d by c. Tan inverse d by c. Is it clear? which will be in the form of x is equal to r angle theta, right? This will be a magnitude, let be r. This will be a magnitude, let angle, that be theta. Okay, let be theta 1 and r1. And y will be equal to another magnitude with another angle, let it be r2 and theta 2. So now you converted this a plus jb and c plus jd into r1 angle theta 1 and r2 angle theta 1. Then you can multiply xy. X into y will be equal to what? Multiply these magnitudes first, that is r1 into r2, and add the angles theta 1 plus theta 2. That is the answer. That is the answer. And suppose you have to find x by y. X by y. How can we do that? That is r1 angle theta 1 divided by r2 angle theta 2. What will be the result? What will be the result? You can divide this r1 and r2 magnitude by division, normal division. That is r1 by r2 you can by normal division. How can we go for angles? Angles will be theta 1 minus theta 2. Theta 1 minus theta 2. That will be the answer. That will be the answer. So suppose you have to go for polar form, means whenever there is a need of multiplication or division, then you can simply go for polar form. This is the very easiest way. Multiplication, multiply the magnitude, add the angles. Division, divide the magnitude, subtract the angles. Clear? Divide the magnitudes, subtract the angle. Multiply the amplitudes, add the angles. In the case of addition or subtraction, you can directly go for complex form representation. You can directly go for complex form representation, that is a plus jb form. That means subtract the real part plus j into subtract the real imaginary part. Suppose you have to go for subtraction, so this is for addition, no? Add the real part plus j into add the imaginary part. If you go for subtraction, subtract the real part plus j into subtract the imaginary part. Bus. So that is the concept of what this phases addition as well as subtraction, multiplication as well as division. So you learned complex form plus polar form, and where it should be applied also you learned, right? Whenever there is a need of addition or subtraction, directly go for complex. Whenever there is a need of multiplication or subtraction, directly go for polar. Is it clear? Is it clear? Okay, let's do that. Let's do an example. Suppose question, write a question. In polar form, V is equal to 200 angle 30 degree. Convert it into rectangular form. Convert it into rectangular form. How can we convert it into rectangular form? How can we convert into rectangular form? How can we convert that? See, this is V is nothing but 200 angle 30 degree. 200 angle 30 degree. Or I can write like this. V is nothing but 200 into cos theta plus j sin theta, simply that. If you want to convert this into rectangular form, this is the easiest way, which is nothing but magnitude is like that, 200. Theta you have to convert into cos theta plus j sin theta. Cos theta plus j sin theta. cos 30 plus j sin 30 plus. Then it will be 200 into cos 30 is nothing but what? Root 3 by 2, correct or wrong? Plus j into 200 into sin 30 is nothing but 1 by 2. So the answer will become 100 root 3. This is 100, right? 100 root 3 plus j into 100. So this is the V in rectangular form. This is the V in rectangular form. If you take in the scope, you have to check, no? You have to check this, no? How can we check for that? How can we check for that? How can we check for that? We can check that also. Suppose this is no A plus J into B. A plus J into B. Whether it is correct or the conversion is correct or wrong, you have to check, no? The conversion is correct or wrong, you have to check. The answer is correct or wrong, you have to check. Okay. So let be V is equal to A plus JB, right? So A is nothing but what? 100 root 3. Correct or wrong? And B is nothing but what? 100. Simply 100, right? 100, right? And what is the magnitude? Let be magnitude. What is the magnitude? This is nothing for check. Check. This is nothing for check, right? So magnitude will be nothing but root of 100 root 3 the whole square plus 100 square. Correct or wrong? Correct or wrong? It is nothing but beta is equal to root of 100 root 3 the whole square is what? 100 root 3, that is a square plus b square, no? A square plus b square, no? A plus jb, right? A square plus b square, no? Which is nothing but 100 root 3, 100 square into 3, right? 100 square into 3 plus 100 square, which is nothing but here. It will be nothing but, beta, listen carefully. 100 square is nothing but 100 into 3 plus 100. Correct or wrong? It will be nothing but root of it will be nothing but correct or beta, correct or wrong? Which is nothing but root of 400 is nothing but what is that? Correct or wrong? Correct. So what was our magnitude here? Our magnitude was 200. We also got 200. So correct the calculation. Let's check for the angle part also. Let's check for the angle part also. What is that? What is that? Let's check for the angle part also. What is that? Here see the equation 100 A is equal to 100 angle root 3, 100 root 3 and B is equal to simply 100. How can we check for angle part? Theta, we know that theta is nothing but tan inverse B by A. Tan inverse B by A, which is nothing but tan inverse. What is B here, beta? It is 100, right? 100 divided by 100 root 3. 100 and 100 get cancelled, which is nothing but tan inverse 1 by root 3. Correct or wrong? Tan inverse 1 by root 3. What is the value of tan inverse 1 by root 3? 30 degree or not, beta? 30 degree or not? Because tan 30 is nothing but 1 by root 3. Correct or wrong? Correct or wrong? You have again doubt. Tan 30 is equal to 1 by root 3 or not? You have again doubt. Tan 30 is nothing but beta sin 30 divided by cos 30. Correct? What is sin 30? 1 by 2. What is cos 30? Root 3 by 2. 1 by 2 into 2 by root 3. So this 2 and 2 get cancelled. It is again simply 1 by root 3. It's simply again 1 by root 3. Correct or wrong? Correct or wrong? So how can we convert a polar form into rectangular form? You learned. It's basic actually. It's a basic question actually, but maybe in problems it's really useful. In problems, many situations you may encounter many situations where you can use this polar to rectangular and rectangular to polar conversion bus. So now you done and you already checked for that. It's correct. The angle is 30, the magnitude is 200. So my conversion is correct. My conversion is correct. Is it clear? Is it clear? Is it clear? Okay. Okay, write a question. What is my time? Okay, write a question. If R1 equal to 10 angle 30 and R2 equal to 5 angle 40, find R1 by R2 and R1 into R2. How can we find? How can we find? Simple question, no? Both are, if you have to multiply or divide, the questions, I mean the value should be in polar form, right? So this is 2 are in polar form, no issues there. So you can directly go for R1 by R2. What is R1 by R2? It is nothing but 10 angle 30 divided by 5 angle 40. It is nothing but make exact division of 10 by 5. It is nothing but 2. Make the subtraction of angle, that is 30 minus 40 is nothing but minus 10 degree. Minus 10 degree. And what is R1 into R2? R1 into R2. Make exact division, that is 10 angle 30 into 5 angle 40. Make exact multiplication of magnitude, that is nothing but 50, and take the addition of the angles, that is nothing but 70 degree. That is R1 into R2 and R1 by R2. Bus. Is it clear? This all are very, very fundamental, I know. Fundamental. Because unless you know these fundamentals, very difficult to solve big problems. Because some part of the problem contain these terms, right? Next question. Find the RMS and average value of the waveform given. Of the waveform. And the waveform is nothing but how can we find this? How can we find this? How can we find this? Find the RMS and average value of the waveform. So for finding the average value, we have conventional equation, right? We have conventional equation, that is nothing but 1 by time period into 0 to t, integral 0 to t into v of t dt. That is conventional equation. But more easy for some waveform, more easy equation is nothing but area divided by time period. This is another equation for finding average value very easily. This is nothing but area of the given curve, area of curve, or simply waveform divided by time period. How can we find for that? In this case, area is nothing but what? Area is nothing but what? Area of triangle, which is nothing but half b into h, right? Half bh whole divided by time period is nothing but t. So, which is nothing but half into what is breadth here? T by 2, right? T by 2 into what is height here? It's simply 1 whole divided by t. Is it correct? Is it correct? Which is nothing but t by 4 into 1 by t, right? So t and t gets cancelled, simply 1 by 4. If it is in volt means this is also in volts. So this is nothing but V average. This is nothing but V average. This is nothing but V average. Is it clear? And let's find what is RMS value. What is V RMS? There is of course no shortcut for finding the RMS value. Our conventional equation is enough. That is nothing but root of 1 by 2 pi integral. So it is not in omega term, right? So simply you can go for 1 by t. No need to write 2 pi at all. It is simply 1 by t integral 0 to t v of t the whole square dt. V of t the whole square dt. So this is v of t, right? So v of t the whole square dt. So first you have to find the value of v of t. That is a difficult task here, finding the value of v of t, right? So what is v of t here? V of t here, we have to find v of t here. So for finding v of t, we have, suppose this is x axis and this is y axis, means we have an equation of straight line which is passing through the origin having slope m, which is nothing but y is equal to mx, which is nothing but y is equal to mx. This is the equation of a straight line passing through the origin, having a slope m, okay. And how can we go for that here? This is nothing but theta, right? Suppose theta is here, let be theta is here, then we have m is nothing but tan theta, right? You know this, m is nothing but slope, which is nothing but tan theta. Opposite side divided by adjacent side. What is opposite side here? It is simply 1. Adjacent side is what? Simply t by 2, right? So 2 by t will be the slope, right? 2 by t will be the slope. So convert it into v of t equation. You have now v of t equal to y is equal to v of t, right? V of t you can go for y and equal to m is nothing but what? 2 by t x. Instead of this x axis, what is the axis here? T. So 2 by t into t will be the equation of this voltage waveform. Right? V of t is equal to 2 by t into small t is the equation of this waveform. Then you can find the values Vrms. Root of 1 by t, there is no changing that. 0 to t, there is no changing that also. V of t, that is nothing but 2 by t into t the whole square and dt. Correct or wrong, beta? Correct or wrong? Correct. And let's see, this is the total time period, right? 1 by t here, it is the total time period. There is no changing that. This is the total time period. There is no changing that. This is the total time period. But see, this is the total time period. See, and the integration should have some limit. No, that is also from 0 to time period t. But in this waveform, you may observe one thing, that the waveform is not existed, or the value of the voltage is 0 when time period is t by 2 to t, or in between this t by 2 to t there is no existence of wave, or simply the value is 0. That means our integration is also from 0 to t by 2 only, because up to this only the waveform exists. Up to this only, this short time period t by 2 only the waveform exists. So this limit is changing, but there is a chance of make a mistake here. Many of our students take 1 by t by 2, it's wrong. This is the total time period. There is no need, we can't change that. This is the total time period of the waveform, 1 by time period. Integral 0 to, you can change for some values, because in integration, no, there should be some values, then only we can integrate, right? So in integration part, the limit part, no, that there we can alter. There we can adjust or alter depending upon the waveform nature. But here 1 by time period, see, t you can't change here. This t is nothing but the total time period of the waveform that we cannot change. Because that is the total time period of the waveform. That's the total time period of the waveform. So that means this t can't alter. But 0 to t by 2, there only they exist. There only the waveform exists. So until this up to this 0 to t by 2, what is the equation? Their equation, t by t into t square dt. There you have an equation like this. Okay, let's see the time. Okay, time is going to finish again. So simply, okay, it will be what, beta? 1 by t. What is that? You can take this t square outside, right? So you can take this outside t square. It's a constant, right? And 2 also you can take outside. That's a 4 has come. And integral this t square dt is nothing but t cube by small t cube by 3 from 0 to t by 2, or which is nothing but beta simply 4 by t cube into 3, this t square, this is t cube divided by 8. Correct or wrong? This t cube and t cube got cancelled, 4 and 2 got cancelled. This is nothing but 1 by root 6. 1 by root 6. So that is the value of what? RMS voltage. That is the value of RMS voltage. I hope you understand this concept. So we can do more problems in the next class. Okay. So bye for today. So stay safe and take care. Okay. Bye.